Formation of secondary pollutants in photochemical smog. Photochemical smog is caused by a series of free radical reactions resulting from the interaction of sunlight with emissions of nitrogen oxides and volatile organic compounds from internal combustion engines. Photochemical smog contains a variety of secondary pollutants such as nitrogen dioxide, aldehydes, PAN, which is peroxyacyl nitrate, and nitric acid. We'll start with the formation of nitrogen dioxide. So nitrogen monoxide is a primary pollutant formed by the combination of nitrogen and oxygen at high temperatures in internal combustion engines. So here's the equation. We have nitrogen plus oxygen, which forms nitrogen monoxide. Next, a secondary pollutant, which is nitrogen dioxide, is formed by the oxidation of nitrogen monoxide with oxygen. So here we have nitrogen monoxide reacting with oxygen to form nitrogen dioxide. In the presence of sunlight, that's UV radiation, the NO2 is broken up to form oxygen radicals. So here we have nitrogen dioxide being broken up in the presence of UV radiation to form nitrogen monoxide and an oxygen radical. These oxygen radicals react with O2 to form ozone. So here we have an oxygen radical reacting with O2 to form ozone. They also react with water to form hydroxyl radicals. So here we have an oxygen radical reacting with water to form two hydroxyl radicals. Next, we'll have a look at the formation of aldehydes. Aldehydes are produced in the reaction of free radicals with oxygen. So here we have a free radical reacting with oxygen to form an aldehyde. Nitric acid is produced when hydroxyl radicals react with NO2. So we have a hydroxyl radical reacting with NO2 to form nitric acid. Peroxyacyl nitrate, or PAN, is a secondary pollutant that causes respiratory problems. PAN is produced by the reaction of peroxide radicals and nitrogen dioxide. So here we have a peroxide radical and nitrogen dioxide reacting to form PAN. And here's the equation. This is our peroxide radical. Here we have NO2, nitrogen dioxide, and this is the formula for PAN. Next, we'll have a look at the graph of concentration of pollutants against time of day. So what you'll see is the concentration of NO is highest in the morning rush hour, around 7 to 8 o'clock. And that's because nitrogen monoxide is produced by nitrogen and oxygen reacting at high temperatures in car engines. Next, we'll have a look at the concentration of PAN. The concentration of PAN increases from 8 a.m. to 2 p.m. That's because nitrogen dioxide, which is a secondary pollutant formed from nitrogen monoxide in the presence of sunlight, forms free radicals that react with hydrocarbons to form PAN.
Photochemical smog is a mixture of pollutants consisting of primary pollutants, nitrogen oxides and hydrocarbons, followed by secondary pollutants, ozone and PAN, which are formed by primary pollutants. So how is photochemical smog formed? To form photochemical smog, a still day with no wind, sunlight, and temperature inversion is required where cold air is below warm air. Also, three main ingredients are needed: nitrogen oxides, hydrocarbons, energy from sun in form of ultraviolet light. The first thing is ozone production. At high temperatures of the car's combustion chamber, nitrogen and oxygen from the air react to form nitrogen monoxide. Some of the nitrogen monoxide reacts with oxygen to form nitrogen dioxide. When the nitrogen dioxide concentration is well above clean air levels and there's plenty of sunlight, then an oxygen atom splits off from the nitrogen dioxide molecule. This oxygen atom can react with oxygen molecules in the air to form ozone, which is a secondary pollutant. Nitrogen monoxide can remove ozone by reacting with it to form nitrogen dioxide and oxygen. This last reaction can go either direction. When the ratio of NO2 to NO is greater than 3, the formation of ozone is a dominant reaction. If the ratio is less than 0.3, the nitrogen monoxide reaction destroys ozone at the same rate as it's formed, keeping the ozone concentration below harmful levels. Since the series of reactions produce a lot more NO2 from NO during a photochemical smog, the ozone concentration increases beyond harmful levels. Next is the peroxyate steel nitrate production. Cars emit hydrocarbons during combustion. Nitrogen dioxide, oxygen, and hydrocarbons react in the presence of sunlight to produce peroxyate steel nitrate. Summary: all four pollutants form photochemical smog: oxides of nitrogen emitted by cars and formed by reactions, ozone which are formed from a series of reactions in the presence of sunlight, hydrocarbons which are emitted by cars, peroxyate steel nitrate which are formed from hydrocarbons. After sunlight acts upon motor vehicle exhaust gases to form harmful substances, photochemical smog is a type of air pollution that occurs. This diagram summarizes the reactions taking place to form photochemical smog. Thank you.
Our atmosphere contains a variety of chemical compounds released from a great number of diverse sources of air pollution. Many of these compounds are toxic, corrosive, and irritating. Under the influence of sunlight, warm temperatures, and water vapor, the polluting substances react with each other in the air to produce new compounds, more destructive and irritating than their original components. Photochemical smog is the most notorious chemical reaction produced in situations of air pollution. Smog occurs when the ultraviolet rays in sunlight set off reactions between hydrocarbons and nitrogen oxides. Gasoline-powered motor vehicles are the major source of hydrocarbons in the atmosphere. Oxides of nitrogen result from nearly all combustion processes.
According to the World Health Organization, air pollution is responsible for 1 out of every 8 deaths globally. In East Asia, 44% of the deaths can be attributed to air pollution. One of the main kinds of air pollution is photochemical smog, which is particularly severe in the emerging megacities of the East. One of these cities is Beijing, with some of the worst air in the world. This presentation will go into more detail about the causes, the impacts, and the challenges that Beijing faces.
Photochemical smog is formed through the interaction of primary pollutants with UV light, creating a hazy mixture of chemicals that remain stationary in the atmosphere. These primary pollutants are formed by incomplete combustion of fossil fuels in engines and factories, producing nitrous oxides that are emitted into the atmosphere. Nitrous oxide molecules readily break down in the presence of UV light, creating oxygen-free radicals that react with oxygen molecules to create ozone. Whilst ozone exists naturally in the upper atmosphere, it has many detrimental effects to the environment and to humans in the troposphere. Smog contains many other secondary pollutants that form as the result of primary pollutants reacting in the presence of UV light. Smog often forms under a temperature inversion, where a body of cold air is trapped under a body of warm air, resulting in very little vertical mixing. This means that emissions that would have otherwise been blown away from the area remain stationary, trapped under the weight of the warm air mass. However, horizontal winds under such conditions mean the smog can spread to rural areas close to the main pollution source.
The consequences of photochemical smog on the environment and humans can be severe. High concentrations of ground-level ozone over extended time can be extremely damaging to vegetation, from trees to agricultural crops, resulting in lower rates of growth, reproduction, and increased susceptibility to insects, disease, and plant death. For people, the presence of photochemical smog at ground level can cause inflammation of breathing passages, coughing, wheezing, and shortness of breath. It can also dry out the protective membrane of the nose and throat, making the body more vulnerable to infection and illness. Seniors, children, and people with existing heart and lung disease are especially susceptible to health risks associated with fine particle exposure. The accumulation of pollutants from photochemical smog also contribute to increasing the greenhouse effect, meaning the production of smog locally can have implications for the world as these pollutants contribute to global climate change.
Beijing, with more than 20 million people, is the 13th largest city in the world. It is located in an area called Jingjingji, a heavily industrialized mega-urban region in northern China, with more than 130 million people living in an area roughly the same size as the UK. This area is the epicenter of photochemical smog in China. The 10 cities with the worst air quality are all in close proximity to Beijing. Every year, more than 1.6 million people die as a result of air pollution in China. In 2012, the damage from air pollution cost China 6.5% of its GDP. If the World Health Organization guidelines were met, 4 out of every 5 premature deaths could be prevented. Industrial activity, the energy sector, and the transport sector are the main culprits and the major polluters in the region.
Beijing took aggressive measures to deal with the air quality during the lead up to hosting the 2008 Summer Olympics, and more recently during the 2014 APEC meeting. Air pollution was reduced by ordering 1.7 million vehicles off the road, shutting down local factories, and mandating that employees of state-owned enterprises take vacation. While these measures made an immediate impact in reducing the amount of air pollution, the extremeness of them has meant that they can only be fully implemented for the duration of these events. In 2013, city administrators released a 5-year plan to improve the city's air quality. The cost of this plan was estimated at $160 billion US.
One objective of the plan is to cut coal burning by more than half. This includes phasing out the use of coal firepower and residential use, transitioning from subsidizing coal to taxing it. Another key initiative involves subsidizing and expanding public transit, in particular the metro system. This is being done in tandem with getting rid of old cars and moving towards the use of cleaner fuel. Road space rationing policies have been introduced, albeit with some challenges. The use of a license plate lottery system to determine what days people can drive has led to a lucrative black market and individuals buying 2 cars so that they have plates for both days.
Even if Beijing was successful at implementing each strategy, the city would still recover the smog from the neighboring region. Thus, coordinated action in the Jing area is indispensable. Furthermore, corruption and lack of transparency makes it hard to tell if progress has been made or not. Only grassroots pressure from the increasingly frustrated locals can eventually achieve change.
Do you know what photo is? Do you know what chemical means? Do you know what photochemical smog is? Well, pay attention, cause I'm about to explain. Photochemical smog, so much photochemical smog. Chemical smog, so much photochemical smog. Because from fossil fuels
now. Steph, back over to you.
All right, thank you so much, Maria. Hey, holiday travel almost on us. That means you're probably getting ready to hit the road, and if you're driving in a big city like LA, DC, Philly, Houston, St. Louis, even Cleveland, you know about smog.
Yeah, those thick pea soup mornings are not good for anyone's health, but the Weather Channel's Dave Malkoff found some scientists trying to beat the problem on this morning's Behind the Science.
Now that's Becky Schwantes. She admits she's obsessed with smog. What is it? Where does it come from? How to get rid of it? Becky, her professor, and her team have just built this.
We're in the smog chamber at Caltech.
The smog chamber is 2 plastic bubbles in a sealed room.
This is kind of like LA's air in here.
Yeah, so we're basically simulating a very controlled atmosphere.
You'll see on the walls there are dozens of lights. Now, if you were in here when those lights turn on, you would end up with a nasty sunburn.
Yeah, they're very similar to tanning lights.
Okay.
And this will affect the chemistry inside the bag.
Now, once we're safely outside, Becky can turn on the lights and fill those bubbles with almost any nasty chemical she wants.
And then we can study how smog forms in the atmosphere.
See, smog is much more than just smoke and fog.
Basically, we'll photolyze H2O2 to generate OH radicals. And OH radicals...
my head is spinning.
Too much, okay. So...
Okay, it takes 3 things to create smog. You mix normal city air with a part of tailpipe smoke called nitrogen oxide, or NOx. When you cook those 2 in sunlight, it turns into smog. NOx, air, and the sun. Those 3 things are right here inside this mirrored box.
Yeah, and that's what we're trying to understand, the specific reactions that occur and how smog is exactly formed.
At Caltech, this smog project is just getting started. For the scientists who work here, it is worth the $35 million it costs to build the lab.
Also, it's important in understanding pollution that affects our air quality.
They want to know how smog affects the lungs and create a new understanding that could shape future environmental laws.
Do you think you'll ever learn how to take a smoggy city and make it not smoggy?
Yeah, I mean, you can do certain things like driving less.
So it's the hard answer.
The hard answer is the way to go. Reduce your emissions and you'll have less smog.
At Caltech, Dave Malkoff, the Weather Channel.
That is pretty cool.
That is cool, but nothing's easy. Getting rid of smog, getting rid of weight. Nothing that's really good comes easy, does it?
No, it doesn't. Coming up on Wake Up with Al, a nation divided this Tuesday.
That's right. Divided by temperature, we'll share who's shivering and who's warm.